Hi, this is Richard C. I'm a math tutor here at Wyzant and answering a question submitted by a student who is probably taking Algebra 2 and probably is just confused by the notation. This is not very difficult to do, really, but the notation can really make it look difficult. So let's go ahead and get this situated and we'll answer these questions. So we have two functions, 2x squared minus 3x plus 1, and then the other function, 3x plus 4. We want to combine these functions in different ways. Well, this notation just means f of x plus g of x. So this is just addition. Okay, so there we are. So this is going to be 2x squared minus 3x plus 1 plus 3x plus 4. So the squared term just stays the same, 2x squared. We'll combine the x terms. You can see that they will cancel each other out. Negative 3x plus 3x is 0. And then 4 plus 1 is 5. And now you can see what I mean. It's just, this is an older notation that I personally dislike. But unfortunately, it's you can still find it on ACT and SAT tests. You can still find it in textbooks. And so it's still something that you need to know. The notation that I'm using is a little more modern. So as you would expect, this is just subtraction. So it's going to be 2x squared minus 3x plus 1 minus 3x plus 4. So the 2x squared is unchanged. But now when you distribute the negative here, you're going to get a negative 6x because it's negative 3x and negative 3x. And then here it's going to be 1 minus 4. It's going to be negative 3. Okay. And then this is exactly what you would expect, g of x minus f of x. So it's going to be 3x plus 4 minus 2x squared minus 3x plus 1. Okay, so once again, we'll start with the squared term. This is just going to be negative 2x squared because you have to distribute the negative. And then you're going to get a 3x plus a 3x, again, because we're distributing. So that's plus 6x, distributing that negative all the way through. And then that's going to give you a negative 1 plus 4 is going to be a plus 3. Okay. This one, as you might expect, is multiplication. It's f of x times g of x. So it's going to be 2x squared minus 3x plus 1 times g of x, 3x plus 4. Okay, so we'll just first distribute these against the 3x. So you're going to get 6x cubed plus, minus 3x squared, minus 9x squared, 9x squared plus 4. So now we'll distribute this first term against the 4. You're going to get plus 8x squared minus 12x plus 4. So now we'll just combine like terms. You're going to get 6x cubed. The x squared term is just going to be negative x squared minus 12x plus 8. Okay, this is division, as you would think. 2x squared minus 3x plus 1 over 3x plus 4. And if you wanted to do this here, you could simplify this using long division. The numerator factors, but it doesn't help us. As you can see, that doesn't help us. And so there's nothing you can do here except long division. You actually could do synthetic division here as well. But you may not have learned these yet. Maybe this is an adequate answer for your teacher. And then this one is just the other way around. We just flip it. And the same comment applies here. You could do long division here. You can't do synthetic division, but you could do long division. I doubt that the teacher is expecting you to do that, but you'll have to check when you get back into class. And that's all there is to it. The really hard ones are coming up in the next lesson, which are called composite functions. And I'll just show it to you just so you get a preview. We're not going to get into the detail. But the notation is an open circle like this of x. You can see it looks a lot like multiplication, where you've got a closed circle, a filled circle. This is an open circle. And then that's the older notation, and the more modern notation would write it this way. These are called composite functions. And these are more difficult than the rest of them here. This is just addition, subtraction, multiplication, and division. This is a more complicated combination of functions. Okay, so I hope that was helpful to you, and I'll see you again next time. Bye-bye.